wanted to do a short video on how to determine the number of tenders that are required when you're going to do a remote seat base operation. So one of the things that they had us do was set a remote seat base operation. Let me see if I can move this down. Over here in Austin. Now, the distance between Mount Augusta right here to Austin Airport is 33.5 nautical miles. Now, if you're traveling at 150 knots, that's going to put you at about a 13.5 minute time frame, flight time one way. So here's what I was encountered with. From the airport driving distance, from here to the first tick mark is about 5 nautical miles, then another mile and a mile and a half, plus another half mile. So it's about 8 miles total one way to go into town, to get to a hydrant, to fill up a water tender, and then come back so that you can be able to mix your load with the LC95 retardant mix tank. So I found myself, when I was doing the math, that probably wasn't going to be all that efficient to have one tender do this. So I immediately requested a second tender. And when we did that, we were running 3-minute operations. So we'd have seats, 750 gallons a minute. And I would take the difference from that and find out, it's like, okay, I got X number of gallons of water that I need. And it worked out to where we were able to launch, or from the time, not launch, from the time that we had the seats come in, they would load and disconnect. It was 3 minutes. So with that, let's go into page 22 of the booklet that I've written and will be published in the next couple of weeks here, which deals with the Wildland Apparatus Engineer's Quick Reference / Field Notebook. And I'll do another video on that pretty soon to talk about that and what it's got in it. But on page 22, I've got tenders required for remote seat operations. So this model here that we're talking about is what I dealt with in 2015 in Austin, Nevada on the Cold Springs fire. So with that, let's continue. A total of 5 seats are at a remote airfield. The airfield does not have a water source, and the nearest source is a few miles away. You are tasked with setting up a water supply for non-stop operations and need to determine the amount of tenders required. So, here's where you start. Number 1. Before you determine the flow, like I've talked about in previous videos, what's the mix rate? What are we mixing this retardant at? Is it 5 gallons of retardant to 1 gallon of water, or 5 gallons of water to 1 gallon of retardant? So that's what you need to determine. Most of the time it's going to be 5.5 gallons of water to 1 gallon of retardant. So then you determine the water-only demand for each plane. In other words, we don't care about the retardant because we're not moving retardant. We care about water. So that's what that means. We only care about how much water does each aircraft need that I have to supply. Take the capacity of the aircraft total and divide by the mix ratio. So 750 gallons total capacity divided by 5.5 equals 136. So that's 136 gallons of LC95 retardant to 614 gallons of water. Then, in number 3, you multiply the water gallons requirement of each airplane by the total number of planes in operation. So for our situation, it dealt with 5. So we're going to take the 614 and multiply it by 5, and we get 3,070 gallons of water total that we need. Now we're going to determine the aircraft's round trip time. So if each aircraft makes a round trip in 15 minutes, then this would allow for 14 nautical miles out, 14 nautical miles back, and then a 5-minute loiter time if the aircraft is traveling at 166 knots. And that's just chosen arbitrarily here. Then in number 5, take the aircraft's combined gallons, divide by the aircraft round trip time to determine the equivalent gallons per minute. So this would look like what you see here is 3,070 divided by 15 equals 204 equivalent gallons per minute. Then over here in number 6, you calculate the water tender round trip time, and equivalent gallons per minute from the equations on previous pages of my booklet here. But basically, it's shown down here. So for those that don't have it, you can see that this is what it is. So you take the total number of gallons of every aircraft and you divide it by the round trip time. That tells you that your equivalent is 204 gallons a minute. Then you take the water tender gallons, useful load, so that's whatever your tank capacity is, subtract 10% off of that, and then take that and divide it by your round trip time. So in this case, it worked out to 22.45 minutes. So then you get down here and you take the 204 and divide it by the 120, you get 1.7. So you round up to 2, and 2 tenders are required to supply 5 aircraft. Now, this solves the water supply problem of the equation, but does not solve the problem of getting the water off the tender and into the retardant mixed truck, tank, or unit, or anything like that. That's just bring the water back to the site and dumping it. It is recommended that what you do is you provide for a 500 gallon per minute at 150 psi pump or tender with that type of a pumping capacity, so that you can rapidly offload that water as fast as possible into the mixing unit so that it could be immediately mixed and sent into the aircraft. That's how I did it when I was at the Cold Springs fire in 2015, and it worked out flawlessly. We never had any hiccups. In fact, the idea and the model that I try to strive for is to make sure that that you are waiting on the aircraft and that the aircraft are never waiting for you. And so that's how you would go about that. So if the distances change and go, let's say it's 3,070 divided by, let's say, 30 minutes, well, then obviously your seat gallons are going to drop in half here. And if the tender stays the same, well, then the tender, it's going to be more closely matched, and then you might have this drop down from 2 to 1 tender. Or if it's faster or you have a larger aircraft, you might need to add another tender or 2. That's not a problem. Pay attention to your numbers, count the time on both sides, and things will happen, and you'll be able to take care of things. You can use this for any aircraft. So let's say you're at a larger airfield, or even this airfield. So this airfield here, another reason I like aeronautical section is this tells me that this is a 6,000 foot runway. How do I know? This 60 right here. That's what this is. And the fact that this is a solid magenta circle tells me that it's a paved runway. The elevation over here is 5,735 feet, and the L means that it's got a lighted airstrip. So everything that you need is on an aeronautical sectional. It will tell you if you understand how to read it, and it's got a legend that tells you what all these things are anyway. But that's basically it, guys. I just wanted to do this quick little video, and hope you're having a good day, and I'll chat later. Bye-bye.